Okay, so we kind of started heat the last day, and we were looking at heat capacity, so we're going to have to continue on, and I know this isn't ideal, but there's nothing we can do except just batter on as best we can. So today you're going to look at a few calculation questions as well as continuing notes. Now, how much heat energy is needed to raise the temperature of 2 kilograms of water from 5 degrees to 100 degrees Celsius? So in this question, water is different than, say, mercury, which is also a liquid at room temperature. Water is different than, say, copper. Different materials require different amounts of energy to heat them. Now, so to do this type of question, we'll always need to get a bit more information here. So in this idea, the specific heat capacity of water is 4,180 joules. So that means that to increase the temperature of water, 1 kilogram of water by 1 Kelvin or 1 degree Celsius, you need to add 4,180 joules of energy. So how much heat energy is needed to raise the temperature from 5 to 100 degrees? Now this is the formula. This is a very important formula. Q is the quantity, I suppose is the heat, the amount of heat added. So that's the symbol for heat, Q. M is the mass. So if you've 1 kilogram of water, then the mass is 1. If you've 10 kilograms of water, the mass is 10. C then is the specific heat capacity of the material that you're heating, which in our case is water. So it will be 4,180. And then delta theta, this is how we pronounce it. That means the change in the temperature. So the temperature is 5 degrees. We want to increase it to 100 degrees. So that would mean that the delta theta in this case would be 95. Now I think we've done this example here the last day. So you substitute them into the formula, and that means that you have to add 794,200 joules. If you had 5,554 joules of heat energy are given out when the temperature of 0.8 kilograms, so that's given to you in grams, you must change it to kilograms, of copper cool from 25 degrees to 7 degrees. Calculate the specific heat capacity of copper. So again, looking at this formula, if I know how much heat has been added or removed, if I know the mass of the material in question, and I know the change in temperature, then I can work out C. So substitute the values in, so 0.8 kg. The change in temperature is 18 because it's gone from 25 to 7. So that allows me then to work out C, which is 385 joules per Kelvin per kilogram. And it says there the mass must be in kilograms. Now the next part. A 2 kilowatt electric heater raises the temperature of 10 kg of water from 15 degrees to 80 degrees. If there is no heat loss to the surroundings, how long does it take? So this 2 kilowatt electric heater means that it's supplying 2,000 watts of energy. So you have to, every second. So to do this question, you have to find out how much energy is required in total. And if you have a 2 kilowatt electric heater, that provides 2,000 watts of energy every second. So first of all, calculate the heat supplied. So, or how much heat energy is needed. So we have 10 kg of water, so the mass is 10. The specific heat capacity of water is 4,180. That means it takes 4,180 joules to change 1 kilogram of water by 1 degree. And then the temperature difference that we're looking for, delta theta, is 15 to 80. So it's an increase of 65. So instead of, you don't have to put in 80 to go away 15 there, you could put in just 65 if you wanted. So on the whole, I need 2,717,000 joules of energy. Now the heat is supplied at a rate of 2 kilowatts. It's a 2 kilowatt heater, which is 2,000 joules per second. The time taken is the total energy supplied over the total energy supplied per second. Now that's not a formula that's written down anywhere, that's common sense. This is how much heat energy you need. This is how much is supplied per second. So divide the amount that you need by the amount that's supplied per second, and that tells you the total length of time taken. Now your Work today during the double class is going to be based on these types of questions, and I'm also going to get you to keep writing the definitions for the next 2 pages. So keep up to date with the work and don't be slacking off.